Let's do this example. It looks a little bit different at what we had before because seems like we have this nice shape for the formula we know. The formula we know is 1 over 1 minus input gives you a series input to the n. N is from 0 to infinity. We know that this equal sign only happens for x less than 1 by absolute value. We have that, kind of, but it's squared, so we don't like it. So before proceeding, we notice the square part, and we're going to do this to get the square in the denominator. Let's do this. How to get from 1 over 1 minus x into 1 minus x squared. Yes, how to get there. So we're using some algebraic tricks, plus or minus, and then factoring out, factoring in. There's one more interesting trick. How to get from 1 over 1 minus x into 1 over 1 minus, or something over 1 minus x squared. What connection do they have? Can you guess? Prime. If you remember, if you take derivative, the denominator is getting increasing exponents. So let's check this out. You can do quotient rule, or you can actually just see it as a chain rule. Both ways will work. 1 minus x to the minus 1. Let's take derivative of that. That comes from the calculus 1 class. Minus 1 goes down, and now you have 1 minus x to the negative 2. Is that correct? Something is missing. Times the derivative of the function inside, chain rule, times minus 1. So this piece is coming from chain rule, times the derivative of the function inside. And that is why the negative actually cancels out, very convenient. So we can now say, I would even say, thus, therefore, in conclusion, to summarize, choose any GRE word you like. 1 over 1 minus x squared. So we found this. Kind of, that's just algebra part. But now, since we know this connection between left-hand side of the formula, now we can figure out derivative of the series. Then, let's find derivative of x to the n. That's easy, that's just power rule. That will be sum, n goes down, x, n minus 1, and the shift happens. So now we're starting with 1 to infinity. So left-hand side was differentiated, and right-hand side was differentiated. Then left-hand side equals to left-hand side, right-hand side equals to right-hand side. That makes sense. Did you see what I'm doing here? I'm trying to find the formula for the new function. Thus, and this is the more important, thus, 1 over 1 minus x squared has a new formula now. Sum n x n minus 1 from 1 to infinity. We got a new function. Not the one we were asked by the homework, but it's the one we need to find the series for the function in the homework. Does that make sense? Yes?
Why did you change n from 0 to 1?
Yeah, because you see, if I keep it 0 and I plug here, it will be x to the minus 1. You kind of, there are two ways to explain. You need to make sure the counter makes sense, and the first term actually is the one that should be. I know the first term if I have the expansion. Expansion for the original function is starting like so. If you plug 0, it will be 1, then plus x squared plus x cubed, plus and so on. When we're differentiating, we're actually losing this 1, because derivative of 1 is 0. So there's a shift happening. Now the first term now is not 1, not the original one. Here we know how it should start as well. Since the first term becomes second, we're making a shift. Or sometimes you can check. If I plug 0 into the n, the first term will be 0, but that's not true. The first term, it's actually going to be 0 times 1 over x, because n equals 0 gives you x to the minus 1. And we don't want it to have that. Division by 0 will not be good also, because x is from minus 1 to 1. So actually there's several ways to explain. Did you understand any? Okay, I hope so. I think I just threw it to you several ways and that made it worse. So we're gonna use this formula, I don't know, let's call it a smiley face formula. People actually creating names for any types of formula, whatever they want, for you to know. I saw a check mark and so on, so very creative. Let's do smiley face. So use this smiley face formula to find the one we need, to find series expansion for, and let's rewrite the one we have. We have 8 over 1 minus 4x squared. Finally, we're gonna do this. This is the most important part. The first step is to have 1 over squared. Well, I'm just gonna get rid of 8 by kicking it outside, like so. Now I have 1 over 1 minus 4x and everything is squared. But I need 1 over 1 minus x squared. Do we need to do anything extra or it's good to go? This is how I recommend you to read it. 1 over 1 minus input squared gives you sum n input to the n minus 1. If you can read the same thing with a new function, you're good to go. And I can 1 over 1 minus input squared. My new input now is 4x. So I can immediately write down the sum 8 times this sum, and the new input is 4x. And we're raising it to the n minus 1. N is from 1 to infinity. This is the most important part, I would say. For the test, we give you the second part. We give you the series expansion, and you need to find the new one for the new function. Does it make sense? I did some algebra, but I feel like sometimes students just get confused what is going on. New input comes wherever x used to be. Makes sense? 1 over stuff squared. This is not the final answer. Let's put 8 inside, and actually we're good to go. The sum is 8n, and also usually the classical answer should have x isolated, but not always. Like in the homework I can see they don't. My point is usually people put 4 to the n minus 1 and x to the n minus 1, but that's not the requirement. From 1 to infinity. But now you see what the input is. So this is the final answer. They want you to find 5 first terms. And also at the end, let's answer the radius of convergence and stuff like that. So let's first write down the terms. The terms will be plug n equals 1. It will be 8 times 1 times 4 to the 0, 1, times x to the 0, 1. So it's just 8. Plus, it's not an alternating series. I don't see any minus 1 to the n part. Plug n equals 2. It will be 8 times 2 times 4 to the 1, x to the 1. Plug n equals 3. You see, I'm not plugging x. I'm plugging n equals 3. It will be 8 times 3 times 4 squared, x squared. Let's plug n equals 4. 8 times 4 times 4 cubed, x cubed. Do you see the pattern? Maybe you're too sleepy, but the pattern is here. 8 times 2 8 times 1, 8 times 2, 8 times 3, 8 times 4. That's the pattern. And then this one is 4 to the 0. 4 to the 0, x to the 0. 4 to the 1, x to the 1. 4 to the 2, x to the 2. 4 to the 3, x to the 3. Those are the patterns. So now if I ask you to find n equals 700, to be honest, it's not a big difference. 8 times 700, 4 raised to the 700 minus 1, x to the 700 minus 1. The same thing. We need 5 coefficients. We don't have enough. Let's do one more. 1, 2, 3, 4, 5. One more is missing. 8 times 5. I don't have to look at the series anymore. I see the pattern. X to the 4. Agree? I just see the pattern. Dot, dot, dot. It is infinite. So 8 times 5 showed up, and 4 to the 4, x to the 4 showed up. Coefficients are the ones that are attached to x. They do not involve x. That's why they call coefficients. They are not part of the x part. So these are my coefficients called c sub n or c sub I, like so. C sub 0, C sub 1, C sub 2, C sub 3, C sub 4. 8. First one is 8 multiplied by 4 to the 0, that's just 8. The second one is 4 times 16, 64. Should I write down? I guess let me write down. 4 times 2 times 8 times 2 times 4, that is 64. The third one is 8 times 3 times 4 squared. 8 times 4 times 4 cubed. 8 times 5 times 4 to the 4. The pattern is pretty clear. 384, 2048, 10, 240. What do you think about this? Yes? Yeah, this one they asked all coefficients, but now they are also the same as non-zero. But then before, we had this nice comparison before. Very good question, thank you. Before, in last class, I explained in both of my classes, my different videos. First 5 might include zeros if there are any. First 5 non-zero will exclude zeros, and you have to find more. What if the coefficients have like 0, 0, 0, 0, 0, 0, 0, 0, 0, and now starts from 100? Then the answer 0, 0, 0 doesn't gonna give any information to the computer. So sometimes we ask you, okay, give me the stuff, give me the juice. Where is the sound start, or where is the wave actually significant? Where is the earthquake of the amplitude that's gonna destroy the city, not the small one? Or, if not necessary, it depends on the problem. We just ask the first 5 coefficients. In this case, it's the same. The first 5 coefficients end up to be non-zero. Did that answer your question? Thank you. That's a good question. Let me put this in the box. One thing left to do. Where do we even, for which x we are allowed to put this equal sign? That means we should find, seriously, that means we should find the convergence set. Nice. The convergence set. Finally, let me write down. What is the convergence set? It's also called interval of convergence, radius, and the center. Center has different notations from different books, so don't get stuck with A. It can be called different, but R usually is R. So we're gonna go back and see which function we were using. Originally, very, very beginning, we were using this formula star. We called it star in the very first class, so that's not new. This is a formula star. It's a geometric series. It only happens for the r less than 1 by absolute value. That r is now x. That's a common factor. So this remains. We showed you theorem on Monday that when you differentiate or integrate, this rule does not change. So the smiley face formula also have the same property. For input x should be less than 1 by absolute value, the theorem says if you differentiate or integrate, this convergence set stays the same. We had it actually at the very beginning of 8.5, I think. So the input should be less than 1 by absolute value. Do you see this note I had? Input. This is my new input, right? New input is now 4x. So what should we do? Who knows? 4x less than 1. Exactly. Solve that. I recommend to divide by 4 right away. X will be less than 1/4. Put this in the box. This is actually already gives all the answer. Radius is 1/4 right away. So the convergence set will be from minus 1/4 to 1/4. That's my convergence set, or interval of convergence with the center 0. Does that make sense? So it comes from the shape, you can see it. We multiplied by 4 the input, so now we have to divide by 4 to shrink the convergence set. Whatever used to be from, I can actually give you a diagram. It used to be from -1 to 1. For this specific case, we shrink the safety, the convergence set, the safety set, where nothing blows up. Now it's from -1/4 to 1/4. That's what happened here. So now the new safe interval of convergence is smaller. Which means if I plug, so you see, I wanted to make sure actually we understand this. This is the series. We are putting equal sign between the function 8 over 1 minus 4x squared and this series 8n 4n minus 1 x minus 1. This happens for all kind of x between -1, 4 and 1, 4, which means if I try x equals 10, it blows up. This equal sign does not hold if I plug x equals 10, x equals minus 100. X equals pi, also not going to work. Pi is 314, blah, blah, blah. So this equal sign only holds for the absolute value of 4x to be less than 1. That's where I'm allowed to use my inputs. Safety place, basically. Make sense? One more problem people stuck with this problem, which is number 4. That's from your homework as well. Let's do this problem. The function is now y equals 6x. So example 2. This is number 4. 6x over 13 plus x. Like that. Looks so much easier, but it just has a trouble. Not only it's plus, but also it's 13 plus. What we're going to do with that? Okay, find the series expansion. The question is always the same. Then convergence set, blah, blah, blah. Solution. As always, we for now using only one formula we know, which is geometric series. Even though last time I started telling you we also have series for arctangent, for other functions, and we're going to find these amazing functions, Taylor-Maclaurin series, which are sine, cosine, exponential. For now, we only know 3. 1 over 1 minus x, 1 over 1 plus x, and log 1 plus x. And also we found arctangent. Arctangent was found by integrating 1 over 1 plus x. Integrating 1 over 1 plus x squared, actually. X squared. Anyway, so you will see it in your homework. This one looks like geometric series. So we're going to use geometric series again. Use formula star 1 over 1 minus x equals sum x to the n. N is from 0 to infinity. 0 to infinity, like so. That's the formula star. We call it star because it's so popular, it's common. So first of all, I see that there's a 6x on the top. 6x over 13 plus x. Let's kick 6x out. 1 over 13 plus x. Basically, it's a puzzle. I'm trying to match the formula I have with something new. And now I have the shape 1 over blah, blah, blah. I like that. 1 over blah, blah, blah. We have that. Now I remember how to deal with the plus sign. I will do minus minus. That is not hard. What is happening with 13? We have to get rid of 13. How do we do that? 1 minus 12, interesting idea, but it's not going to work. In this case, 1 over. Let's factor it out. Exactly. That's a good one. Good job. 6x is outside waiting. 1 over, and I will just factor it out. 13. Factor it out. Now I have 1 plus x over 13. Does it make sense? Now it's getting better. It's getting better. We have a shape 1 over 1 plus stuff. So remember, I read it like this. 1 over 1 minus input. So I'm getting closer. I'm getting closer to that. 6x, let's put over 13. Over 13 equals, oh, not equals, times 1 over, and now I have 1 plus x over 13, but I need 1 minus. What do? Minus negative. That's the common one we did many times. Now we're ready to use the formula. Let's check again. I'm saying it out loud. That's the best way to figure it out. 1 over 1 minus input equals sum input to the n. Do I have that? 1 over 1 minus input. Yes, I have that. Let's do it. 6x over 13 times this sum. New input is minus x over 13. Will go everywhere. I see x. So sum input to the n. New input is minus x over 13. Let me put it in red color. Minus x over 13. Minus x over 13. N is from 0 to infinity. This is how we use the formula. We're almost done. Does it make sense? This step was pretty challenging. We did some algebra and we succeeded. It looks easy when, or maybe it's not, but it looks easy when I'm doing. Can you do it by yourself though? Factor it out first. Then minus minus. Now we have a nice shape. We're working with this stuff in parentheses. That's the one we're trying to convert into the series. And we succeeded. Make sense? Questions? Yes.
So the input only goes into the sum and not into the x, the 6x?
Very good question, exactly. So this x is waiting outside, and that's why we don't touch it. Very good question. Did you ever actually question that? I did, right? Why we did not substitute the new input minus x over 13 into this guy? Because it's not in the sum. So we're using blue formula only for this part. Use star. That's what we're doing. The other one waiting outside. Make sense? Yeah. Thank you. This is a very good question. Let's finish. Now we're going to distribute, or basically submerge 6x over 13 into the sum. 6x over 13. And then this minus x over 13 is keep waiting. Seriously. Minus x over 13 is keep waiting. And it's from 0 to infinity. If you have struggles with this step, write down carefully everything. So we will have 6 over 13. We have x. We have minus 1 to the n. That's the first thing I see. It's alternating series. We have x to the n, and we have 13 to the n. So I just put each individual term, a factor. Each factor now is standing by itself. That's what I did. And now I know how to collect terms. That is going to be the sum. Let's do what first, probably minus 1 to the n usually goes first. To show people it's alternating series. Then it's 6 over 13. That's the coefficient, doesn't depend on any n. Then x raised to what power? n plus 1. Exactly. Okay, see, seriously. N plus 1. So it was n, and it was 1. N plus 1 over 13 to the n. That is the final answer in the series notation from 0 to infinity. This is the sum for the function 6x over 13 plus x. Questions before I move on to the terms? What do you think? How do we submerge it? So usually it's a multiple choice in a test. You have like 5 different series and you need to choose the correct one. One will have just x to the n, no n plus 1. The other one will not have minus 1 to the n. And you should notice it must be alternating, so that's the wrong one. And so on. Now let's write down the first 5, just 5, not non-zero, coefficients. So let's write down 5 terms. When n is 0, minus 1 to the 0 is 1. 6 over 13 stays. X stays over 1 because it's 13 to the 0. So it's 6 over 13 x. Is it correct? I wonder if it shifted to the minus 1. Let's check. Should not be. To the 0. Oh, we multiply. No. Okay, fine. Let's keep it. Is it correct when n is 0? Looks good to me. Plus, when n is 1. Now we know it's going to be minus, plus minus, plus minus, plus minus. 6 over 13. When n, so maybe let me write down. N is 0, n is 1, n is 2, n is 3, n is 4. Let's write down. When n is 1 is 6 over 13 with negative sign, x squared over 13 plus, when n is 2, it will be positive, 6 over 13 x cubed over 13 squared, minus, when n is cubed, 6 over 13 x to the 4 over 13 to the 3, plus, do you see the pattern? Let's concentrate. The pattern is 16 over 3 is always the same because it's a coefficient. It doesn't have any dependency on n. Then we have plus and minus, plus and minus, plus and minus, starting with plus. Then we have 13 to the 0, 13 to the 1, 13 to the 2, 13 to the 3. So I already know it's going to be 6 over 14 with 13. Plus, because it was minus before, 13 to the 4, makes sense? And it was x to the 1, x to the 2, x to the 3, x to the 4, x to the 5. This is actually too many terms. I will show you in a second why. They ask for the first 5 coefficients. N equals 4. Coefficients, not terms. So let's see what's happening. So also plus, keep going forever. Coefficients are the ones that are attached to the x. So the first coefficient, so this is coefficient we see. And this one is attached with negative sign to the x squared. And 6 over 13, 13 squared. And minus 6 over 13, and so on. C sub 0, C sub 1, C sub 2, C sub 3, C sub 4. And now I'll show you the mistake, so you don't repeat it. Let's have a mistake, and then you don't have to repeat it. In the previous example, the first coefficient was a number standing by itself. Standing by itself means attached to the x to the 0. The first coefficient is a sub 0, basically, or c sub 0. The formula requires us to find the coefficient that is not attached to any x. Or I can always say it's multiplied by the x to the 0, this one. If you don't see it in front of you, you put 0. The first coefficient always have to be the isolated one. That is important. So Do I see it in front of me? No. Let's check in my case. My series starts expansion with x to the 1. See? Thus, I have to remember, the first one should be x to the 0, then it's x to the 1, then it's x squared, then it's x cubed, then it's x to the 4. X to the 0 is missing, so the coefficient is 0. Basically, there was like 0 plus at the very beginning. It's just not there. And because it's missing, we're going to put 0 there. Does that make sense? That's the tricky part. It was shifted to the right by 1. To indicate it properly in the computer or in general in math, you put 0. Now everything is whatever you see. 16 over 13 over nothing actually. So it's just 1. That's the answer. 6 over 13. Minus, don't forget alternating sign. Plus, minus, plus, minus. 6 over 13 times 13 plus 6 over 13 times 13 squared minus 6 over 13 times 13 cubed. You see, I keep it as a pattern. So if anyone wants to ask me now, c to the 15, I can actually figure out the pattern quickly. That is the coefficient answer, and we still need to do convergence set. Does that make sense what we did here? The coefficient stuff. Let's put it in the box and find the convergence set. Is it different or not? We'll see. We were working with the function geometric series. Original restriction was absolute value of x should be less than 1, but it was original input. My new input changed to minus x over 13. New input is minus x over 13 is less than 1. So we need to solve for that. Don't be bothered by the negative sign. Absolute value gets rid of it. So, same thing as to say x over 13 is less than 1. Multiply by 13, x by absolute value should be less than 13. That immediately indicates the convergence set. Convergence set or interval of convergence is from minus 13 to 13. Radius is a step size 13. Center is 0. Does that make sense? As you can see, we as power series, we don't really deal with shifts that often. Usually it's centered at 0, and you just need to carefully solve the inequality for the new input. The new input for the geometric series. They were both geometric series, but the new one has different input. Yes?
When would the center ever not be 0?
Yeah, you will see it later. If the center was x minus 7, then by absolute value it will be less than 1, and now you have to have a different center. That's going to be 7, right? Do you know how the function will look like? Just imagine 1 over 1 minus x minus 7, like so. That immediately will have a shifted center and a different radius. Good question, though. That's the example when center is not 0. Good question, people. Good job. Very impressive that you are awake in the cold morning.